Okay, so get this right. Imagine a world where we can custom design proteins to do, like, just about anything.
Anything.
Yeah. Battling diseases,
Amazing.
gobbling up plastic. That's the kind of crazy potential we're talking about today, and it's all thanks to the incredible work of the 2024 Nobel Prize winners in chemistry.
It's like we've unlocked the secrets to building with the tiniest Lego bricks of life amino acids.
Wow.
These discoveries aren't just about understanding proteins, it's about creating like entirely new ones with mind-blowing possibilities.
Exactly. You know how proteins are these essential little machines that keep our bodies running?
Mm-hmm.
Well, we're not just finding them anywhere, we're building them from scratch.
Yeah.
And to help us unpack this incredible breakthrough, we've dug deep into all the research and Nobel Prize buzz. So get ready for your crash course in why everyone's freaking out about proteins.
And why you should be too, because this isn't like some far-off science fiction.
Right.
This is happening right now
Yeah.
with real-world implications in fields you wouldn't believe.
Oh, absolutely. So let's start with the brains behind this revolution, right?
Right.
David Baker. This guy's like the ultimate protein architect.
Yeah, he really is.
He figured out how to assemble those amino acid building blocks into completely new protein structures.
Yep.
Ones never even seen in nature.
Yeah, what's remarkable is Baker didn't just discover these new proteins, right? He created a program called Rosetta, a tool that allows researchers around the world to design proteins with specific functions, almost like, writing a code for life.
So it's like giving scientists the ability to whip out proteins with, like, superpowers on demand.
Yeah.
But designing a protein is one thing, right? Figuring out its shape and what it actually does, and that's a whole other challenge, right?
Absolutely. Think of it this way. You find a key.
Mm-hmm.
Just by looking at its parts, you might not know what it unlocks, right?
Right.
But if you know its exact shape, you can understand its function. That's what determining a protein structure does for scientists.
Mm.
And it used to be a painstakingly slow and expensive process.
Enter stage left. Demis Hassabis and John Jumper, the masterminds behind AlphaFold 2. This AI tool is like having a superpowered microscope that can predict a protein's intricate 3D structure just from its amino acid sequence.
Amazing.
This was a problem that had stumped scientists for decades.
And it's not just a, cool tech trick. AlphaFold 2 is being used by over 2 million people across 190 countries.
Wow.
For example, because of AlphaFold 2, scientists are closer than ever to understanding antibiotic resistance, which could save countless lives. It's changing how we do science, literally.
Okay, so we've got the protein architects building these incredible structures, and we've got AI predicting their shapes and potential. Now, let's talk about the real-world impact. Where do we even begin? This feels huge.
And it is. But before we dive into the practical applications, let's take a moment to appreciate the magnitude of what we're discussing, right? We're talking about understanding the fundamental building blocks of life at a whole new level and being able to manipulate them in ways we never thought possible. It's like we've stepped into the future. It's true. We're at this incredible point where we're not just observing nature, we're actively, shaping it at its most fundamental level. And one of the most exciting areas where this is playing out is in medicine.
I can see why medicine would be at the forefront. We're always looking for new ways to treat diseases and, heal the body. What kind of medical marvels are we talking about with these protein power tools?
Well, picture this, right? Instead of traditional drugs with potential side effects, we're talking about proteins designed with pinpoint accuracy. Imagine microscopic surgeons delivering treatments directly to diseased cells or even repairing damaged tissues at the molecular level. That's the promise of protein-based therapies, and it's, becoming a reality.
So we're talking about a whole new level of targeted treatments, potentially with fewer side effects. That's huge.
Exactly. And it's not just about treating diseases after they, strike. It's about preventing them in the first place. Think about vaccines.
Oh, right.
With protein engineering, we can design vaccines that trigger a very specific immune response, making them more effective, safer, and quicker to develop. This is going to be crucial as we face new and emerging diseases.
Okay, so we've got disease-fighting and disease-preventing superproteins, but it sounds like this technology goes way beyond just medicine.
Absolutely. Remember how we talked about proteins being nature's building blocks? Well, now we can design them with properties that go beyond anything found in nature. Think like stronger than steel materials but as light as a feather.
Wow.
Or self-healing fabrics that mend themselves.
What?
It sounds like science fiction, but it's quickly becoming our reality.
Self-healing fabrics. Now, that's something I could get behind. It sounds like we're on the verge of a materials revolution.
We are. Researchers are already using protein engineering to create these next generation materials for everything from aerospace engineering to the phones in our pockets.
Wow.
And it doesn't stop there. We're even tackling some of the biggest environmental challenges with these advancements.
This is what I find so fascinating. We're talking about this tiny microscopic world of proteins having this massive impact on the world around us. So how are we using them to, protect the environment?
One word, plastic.
Okay.
Plastic pollution is a huge problem, but researchers are developing enzymes, a type of protein that can break it down much faster than ever before. Imagine cleaning up landfills and oceans with these little protein powerhouses.
Wait, proteins that literally eat plastic. This is blowing my mind.
Okay.
And to think this all goes back to understanding how these tiny proteins are built.
It does. It all starts with those amino acids. And the more we learn about how to manipulate and control them, the more we realize the potential. We're seeing progress in areas like bioremediation, where we use proteins to clean up pollutants, and sustainable agriculture, to develop more resilient crops.
It's really incredible to think that we can now harness the power of these tiny biological machines to solve some of humanity's greatest challenges. It's like we've been handed the keys to a whole new world. It's like we've gone from reading about, futuristic inventions to actually holding those inventions in our hands. But with all this incredible potential, it does make you wonder what's next for this protein revolution.
That's the million-dollar question, isn't it? And the exciting thing is we're just at the tip of the iceberg. The discoveries we've been talking about today, the ones that earned these scientists the Nobel Prize, have basically given us the blueprint to a whole new era of scientific advancement.
So what you're saying is this is just the beginning. We figured out the basics, and now the possibilities are like almost limitless. It's both exhilarating and a little daunting at the same time.
Exactly. And that's why these discoveries are so groundbreaking, right? We're talking about potentially changing the world as we know it. But like with any powerful tool, we need to make sure we're using it responsibly.
It's like we're holding the keys to a brand new sports car. Before we hit the gas and speed off into the future, we need to make sure we know how to drive it.
Exactly. And that's where you come in, our listeners. As we keep exploring this new frontier of protein engineering, it's going to take all of us to think critically about the implications, the possibilities, and yes, even the potential risks that come with this level of scientific advancement.
It's a collective responsibility then. We've gone from understanding how proteins work to actually designing them. And now we need to make sure we're using that knowledge wisely.
Precisely. And it all starts with staying informed and curious. Today, we've taken you on a deep dive into the incredible world of protein engineering, from those tiny amino acid building blocks to the groundbreaking work of scientists like David Baker, Demis Hassabis, and John Jumper. We've seen how these discoveries have the potential to revolutionize everything from medicine to materials and even how we protect our planet.
It's been quite a journey. We've explored disease-fighting proteins, self-healing fabrics, plastic-eating enzymes, so much more. It's clear this protein revolution is going to touch every aspect of our lives.
And as we wrap up, we want to leave you with this final thought. If you could design a protein to solve any problem in the world, what would it be? Let your imagination run wild, and who knows, maybe you'll be the one to make it a reality. Keep exploring, keep questioning, and keep diving deep into the fascinating world of science.